It is necessary to identify which molecular gas petals are the Monster Hadron Collider before moving on to the statement. The LHC which CERN operates is a 17-meter ring of superconducting magnets and, similarly, the most famous and significant particle smasher in the world. It is the height of human scientific achievement. In fact, it is so powerful that it could replicate the actual states of the first interaction on Earth. However, could this device, which was meant to unlock the mystery of the universe, pave the way for something else entirely? CERN, which was established in 1954, is one of the most well-known research organizations in the world, with 23 member states and countless researchers. Although the LHC is CERN's main project, it is only a piece in an enormous system of tests and gas pedals. Imagine a course that focuses more on subatomic particles than cars or people in order to practice talent, diligence, and space itself. The LHC accelerates protons to almost the speed of light, putting them on a collision path that captures the universe's energy at the moment of the Big Bang. The impacts produce temperatures that are typically hotter than the sun's center, and a vast number of magnets direct the protons on their journey while intricate cooling systems maintain the magnets at temperatures lower than space. The LHC's pillars are designed to crash at 4 districts around the gas pedal ring, connecting with the locations of 4 molecule identifiers. CMS Alice and LHCb each serve an unparalleled purpose by looking into extraordinary molecule material science fragments. Together, they function as beast cameras, recording images of these accidents, and experts sift through the debris in search of signs of the slippery Higgs boson, also known as the God molecule, and other anomalies that provide fragments of the universe's fundamental building elements allow us to focus on the microcosm and learn more about it. But every response raises new questions, and every revelation leads to new tests. The LHC is more than just a logical tool. It is a manifestation of human curiosity and advancement. In any case, as we push the limits of our knowledge, we should also consider the more existential and serious questions that come up, such as what are the risks of examining the unknown and our primary objective for witnessing unexpectedly open forces over which we have no control. In the hallowed halls of CERN, where the limits of human understanding are constantly pushed, a revelation has emerged that chills even the most well-prepared research seekers. Former CERN scientist Brian Cox is an authority in the field of molecules. Recently, physical science has made a statement that has both fascinated and unnerved people worldwide. Cox's comments echo with depressing clarity. The aim of CERN's Massive Hadron Collider is to replicate a small-scale Big Bang. Yes, you read correctly. A miniature recreation of the event that created our universe. The physicists also managed to make sense of the implications of this goal, highlighting the LHC's incredible capacity for new discoveries. This includes its ability to reveal the Higgs boson's privileged secrets and explore dark matter, an odd substance that constitutes a crucial component of the universe. Imagine being able to grasp the force of creation. The ability to call forth the universe's actual embodiment is an alluring opportunity, but it is also fraught with danger. The scaled-down Big Bang is more than just a theoretical concept. It is a significant fact that exists inside the LHC. The temperatures, tensions, and crude energy all replicate the states of the universe's introduction to the world. It's like being at the beginning of written history witnessing the introduction of presence itself. Nevertheless, with such power comes responsibility and the question of what if something goes wrong. In fact, back in 1978, the Russian physicist Borsky encountered a catastrophe that would permanently alter the course of his life when he was working on the U-70 synchrotron at the Institute for High-Energy Physics in Kyiv, Russia. A fizzle caused his head to accidentally come into the direct path of a proton beam, which entered his skull with an opposing force, entered the back of his head, and exited through his nose. Borsky had an incredible experience. He saw a fire that was 1,000 times brighter than the sun, yet he was stress-free. This episode isn't just a personal tragedy. It serves as a reminder of the terrifying power and potentially dangerous dangers of molecule gas pedals. The beam's path left a path of destruction, consuming tissue and bone, but he remained conscious and even walked to the center for treatment. The outcome was both upsetting and captivating. The beam's path caused limited tissue harm, leading to hearing loss in one ear and partial facial paralysis. But surprisingly, Borsky's intellectual resources stayed intact, and he continued his scientific career. The potential for frightening responses is one of the hazards of a particle smasher like the LHC, which should not be underestimated. The fundamental fabric of existence being altered. These are real worries expressed by some respected experts, not the stuff of science fiction. The possibility of creating a tiny black hole is one of the most disturbing and fascinating issues related to the LHC's testing. Researchers and the general public find it astounding that the LHC could create such a substance, even on a small scale. Black holes are regions of spacetime where gravity is so strong that not even light can escape. They are enormous vacuum cleaners, devourers of stars, and strange substances that hide in the shadows of our universe. Could this black hole eventually grow wildly, gulping the Earth from the inside? CERN researchers have assured the public that any black hole created would be unsteady and vanish very quickly. Regardless, the remote possibility has sparked discussions, fears, and awe at the power we possess. When protons are crushed together at nearly the speed of light, the energy created is so enormous that it twists the texture of spacetime itself. For example, if a heavy object is dropped onto a tautly stretched trampoline, the texture will twist and, if the object is heavy enough, it may create a depression so deep that anything nearby would be drawn into it. This has to do with the fundamental mechanics of molecules and gas pedals. In the field of quantum physics, where the rules of the world are both strange and amazing, there is a theory that more dimensions may be concealed inside our existence. This is a simplified comparison for what might occur at the LHC. If these dimensions are real, the LHC's research could use them to create a gravitational well that creates a tiny black hole. Some incredibly well-known scientists have even expressed interest in the strange dance of particles, especially the late Stephen Hawking, who in his book warned that the Higgs boson could become unstable at very high energy levels. This instability could result in a catastrophic vacuum decay that would not only destroy the Earth but could potentially destroy the entire universe. In his book on the future prospects for mankind, renowned English cosmologist and astronomer Sir Martin Rees examined the possible risks of particle collider testing, including those at CERN. He also voiced worries about the experiments carried out there. His remarks were not only wise, but also tinged with existential fear. He spoke of the worst-case scenario, in which a botched experiment may result in vacuum instability. Although he gave a low probability of these catastrophic outcomes, he contended that even a remote possibility merits careful consideration because the stakes are definitely high and the margin for error is extremely thin. This instability could theoretically cause a phase shift that would reverberate through the fabric of spacetime, resulting in a catastrophic event that could engulf the entire universe. In fact, Brian Cox acknowledged the significance of this, acknowledging the widespread concerns surrounding the activities at the LHC. He underlined that there are extensive safety measures in place, thorough reviews, and protocols to ensure that the LHC's operations are carried out with the highest possible level of attention to detail. CERN specialists have run simulations, examined the theories, and taken every precaution to ensure the safety of the LHC. Cox reassured him that the energies involved are well within what the Earth naturally experiences, and that the chances of creating a stable black hole are cosmically low. Even if one were created, scientists say it would be so small and unstable that it would dissipate quickly in an energy eruption, a phenomenon predicted by Stephen Hawking and known as Hawking radiation. This would be a brief moment of massive wonder, a fleeting glimpse into the void, and then gone. Some have even gone so far as to speculate that the LHC's experiments could open a portal to another universe or dimension. Although mainstream scientists largely reject this theory, it has captured the imagination of many people and has become a topic of interest, fear, and even lend the question of what lies beyond our universe. Could we unintentionally unleash forces or entities that we don't understand? The notion of creating a portal to hell has even been sensationalized in the media, stoking skepticism. But how did this notion come to be, and what does it signify for scientific research? The idea of additional dimensions in string theory physics is not new. There may be more dimensions to space than the conventional three, according to a prominent candidate for a unified theory of everything. These additional dimensions may be compressed or obscured from our view, but in certain extreme cases, they may be accessible or made visible. Imagine the LHC as a cosmic key that unlocks doors that have been locked since the beginning of written history. When protons collide at energies never before attained on Earth, they may theoretically produce ripples or waves that probe these hidden dimensions. If these dimensions exist, the LHC may even reveal them, but before we get caught up in wild speculation, it's important to realize that, despite the LHC's obvious power, there is no concrete evidence that it will open a portal to another universe, let alone to hell itself. Nevertheless, the fascination of the unknown combined with the enigma of quantum physics ensures that such concepts will continue to captivate the public imagination. So should we be concerned about the LHC and its possible risks? The truth is that the scientists at CERN are well aware of the risks involved, have taken all necessary precautions to ensure the safety of their experiments, and continue to monitor and assess their work with the utmost diligence. It's easy to get carried away by dramatic headlines and fears of a worldwide catastrophe. The potential advantages of the study, the improvements in our knowledge of the cosmos, the finding of new particles, and the investigation of dark matter are simply remarkable. It's a window into the very core of the cosmos as well as a display of human brilliance. Nevertheless, like any significant scientific advance, it has risks, so we should approach it with a healthy dose of amazement. Courtesy and prudence, the frontier of scientific investigation, where theoretical physics and experimental reality converge, is symbolized by the enormous Hadron Collider. The LHC still inspires awe and fear in some people despite extensive safety precautions and careful calculations. The machine's sheer size and the energy it generates are astounding, and each new experiment opens up new scientific vistas. Although the majority of researchers are confident about the safety of LHC experiments, there are clear vulnerabilities. Nevertheless, its true potential to answer fundamental questions about the universe, such as the origins of mass and the nature of dark matter, is unmatched. The LHC pushes the frontiers of human knowledge and our ability to regulate the natural world as particle collisions replicate circumstances unseen since the Big Bang. But what if new, unexpected abnormalities emerge that cast doubt on our comprehension of physics and the rules of the universe? The importance of these experiments prompts existential concerns on the possible results of changing the universe's fundamental composition. Nevertheless, the LHC has made significant contributions to particle physics, including the discovery of the Higgs boson, which has improved our comprehension of the Standard Model and created avenues for future discoveries that might influence our technological future. The quest for knowledge is still one of humanity's most ambitious efforts, despite the dangers. There are always risks associated with scientific discovery, and the LHC is no exception. For decades, tests delve into areas of physics where intuition is no longer relevant. Physicists have attempted to comprehend nature's underlying forces. Electromagnetic gravity, both the strong nuclear force and the weak nuclear force, are essential to the evolution of matter.